All right, welcome back for another Green Builder Media webinar. Did you know that smart is cool? Well, at the very least, it is today, because today is Smart is Cool Day. Yeah, I didn't know about that one either. But it does feel good to be surrounded by a lot of cool people. So, what are we going to be learning about today to help us all become even cooler? Why, it's the latest International Energy Conservation Code, or the IECC as it's known for short. We'll discuss compliance paths, documentation requirements, key changes, and strategies for maximizing energy cost savings. Now, keeping with the spirit of today's observation, our guest is a cool cat. We're welcoming back Shaunna Mozingo, Code Projects Manager at Noresco. Through her work, which includes being a plans analyst and inspector, Shaunna has provided code adoption assistance and code training to many jurisdictions in the U.S. and beyond. She is a past president of the ICC Colorado chapter and has served on several of the IECC code development and correlation committees. And finally, Shaunna is a recipient of the Department of Energy's prestigious Jeffrey A. Johnson Award for her work in building energy efficiency and codes. Now, whenever we have a webinar about codes, it's a pretty good chance it's sponsored by our good friends over at NV Energy. They have this wonderful tool called PowerShift. It helps residential and business customers conserve energy and save money on their power bills. PowerShift is a one-stop resource to find energy-efficient products and services. For more information, please check out their website at nvenergy.com/PowerShift. Now, during the course of today's presentation, you can submit questions for our guest. Simply use the Q&A box at the bottom of the Zoom window. I'm going to look over those questions and pose those to Shaunna during the Q&A time that we have set aside after her presentation. All right, Shaunna, are you ready to drop some knowledge on us?
I sure am. Thanks so much, Mike. It's awesome to be here today. Loving it. All right. First, just real quick to get started, I'm just let you know that if you're tuning in from Colorado, Colorado would love to hear from you. So this is just a little thing for Colorado. If you are here, if you could sign in and let us know you're here, that'd be awesome. The Colorado Energy Office likes to keep track of when I teach. So that's just a little thing for Colorado. So if you have time to do that, great. All right, so we're going to talk real quick about the 2024 IECC. We'll focus on residential just because we don't have a ton of time, and sometimes it gets a little crazy if you try to put too much into one thing. So just a couple things to keep in mind, that the 2024 is the latest edition. In fact, code hearings are going right now for some of the 2027 codes. Not energy, they're not at the hearings. They're being written in a separate process now, but they're still taking place. So we're going to talk about the 2024, what's kind of changed really high level. And then we're going to talk about what I see coming in the future based on what's happened over the last couple cycles, what's happening in all the different states that I'm in. And then really hope to get you all engaged at the end with a lot of great questions. So let's just talk about one of the things that comes up all the time with this code is the intent. What is this code is, the energy code, what is it even supposed to be doing? And so forever there was this intent that said it was, one little paragraph saying that the code shall regulate the design and construction for effective use and conservation of energy over the life of the building, always provide flexibility. That's why we have so many different paths of compliance and so many different options, right? We're going to provide flexibility, permit innovative approaches, don't hinder technology advances, and above all else, don't abridge safety, health, and environment. One paragraph says a lot. But over the years, there have been some new things trying to make it into the code. And so I know this, when we were writing the 2024 code, there were some challenges on what got put into the code, whether it was on electrification or EV charging, or some of the things that some people felt weren't base minimum, or maybe weren't good for everybody. And so things start getting challenged. They went to appeals hearings, ended up getting pulled out of the code when it got published. It happened in 21, happened in 24. And so one of the things that was brought up in those appeals hearings is the fact that when you have an intent like this that says it's, for the design and construction for effective use and conservation of energy, people were challenging how does electric vehicle charging requirements conserve energy of the building? Actually, doesn't it use energy of the building? And because of those types of reasons in the appeals, those electric vehicle charging requirements didn't make it into the code. So ICC Board of Directors went through and redid the intent. Now here's your new intent, right? It's pretty big. And so they're trying to cover everything so that if something does go to appeal or that, they're kind of, the intent of the code has got it covered, right? So we still have this, the residential provisions provide market-driven, enforceable. You're going to see all kinds of new words in here, right? Enforceable, market-driven, minimum efficiencies, which it's not said that in a long time. Is this the minimum or are we going above? It's, they're saying it's minimum efficiencies, keeping things safe, technologically feasible, cost-effective, all kinds of things that have never been in there before. Then they add another one. Additionally, the code provides jurisdictions with optional appendix chapters, optional supplemental requirements to get to zero or, to achieve zero energy buildings, all of those kinds of things. You still have the option of doing it, but it is an option. You can adopt the appendix chapters or utilize the supplemental resources that we'll talk about. Also, again, reiterating, there's some appendix chapters in there that are not mandatory unless the jurisdiction adopts them, but that can take it above minimum to deal with carbon emissions and those types of things that jurisdictions are looking for. It's not limited. There has to be a prescriptive and a performance path, right? And I like this. I don't know if they lived up to it, but the code will aim to simplify code requirements to facilitate the code's use and compliance rate. I don't know if we manage simplifying it in some of those areas, especially commercial, but it's nice that it's in the intent. It's updated every 3 years with a subsequent addition providing increased savings. So that's letting everybody know that there is this intent that each additional cycle will build on it. It will never go backwards. So that's good to know. And that the IRC Energy Code chapter comes straight from the IECC in residential provisions. And then keeping the same sentence in there about provide flexibility, don't abridge safety, health, and environment. So we went from that one little tiny paragraph to all of this in hopes of covering everything that we could possibly throw at this code. So that's interesting. So a couple of things. There are some places in the code that do mention like solar or maybe demand response controls or things like that. But it just lets you know that where you install them, they have to do them, or where you do this, it has to meet the requirements. It does not require that you do it unless your jurisdiction requires it. So I just want to clarify that, when it says there's solar ready systems in 105, it doesn't mean you have to do solar ready systems. Where you provide solar ready systems, here's the requirements for that. This is for what you have to put on the construction documents to show those solar ready systems. So just want to reiterate that. I get a lot of questions like, it's in the code that you have to do solar ready. Only if your jurisdiction requires it. All right, some new stuff that went into the code, definitions, of course, those are, I always tell people when you get a new edition of the code, if you want to know where it's going, you want to know what's ahead of you in those multiple pages. It's getting bigger and bigger every time. It'll be as big as the IRC pretty soon. If you want to know where it's going, turn straight to chapter 2, right? You see all the new definitions, right? And some of the revised ones. But when you see new definitions, you can kind of see, okay, here's what's coming at me. Always go there. Also, always reiterate to everybody that you cannot use this energy code or enforce this energy code or design to this energy code without looking in chapter 2 all the time. If you don't know the definition of conditioned space, for instance, there's no way you're going to enforce this code correctly, because it's not what you think. It's not just about heating or cooling a space, right? There's a lot more involved in it. It's whether or not your ducts are insulated, or whether or not your wall between two spaces is insulated. There's a lot that goes into conditioned space, and whether you have to comply with the code. So make sure you're really looking at those definitions as you're going through this code. Some new things that got added. This is a new thing. It's been in commercial for a couple code cycles now, but it's just got added to residential. This idea that air actually has some good thermal properties to it, as long as it's not moving and it's not exchanging air with another space, right? So if I have a vented airspace, if I have air moving in and out of my cavities, that's not great. I can change temperature, I can change humidity, I can change all kinds of things wherever air moves. But if I can seal up this cavity really tight, and now my air is just moving within the cavity, that kind of movement is okay. I'm not moving in and out, so I have less chance of changing temperature and things. If I build a really tight cavity and I don't have air moving in and out, I can use that airspace. I could use that air as part of my R value. There's a whole ways of figuring out what that R value is and everything, but it's in there now. It's like I say, it's been in the commercial for a couple cycles. I've never seen anybody propose it or use it, but it's in there, especially now that we're building tighter and tighter buildings and we're getting less air movement. Maybe it is good to use some of that air towards part of your R value. So just interesting things that make it into the code. Another thing that made it into the 2024 are the radiant barriers. So radiant barrier folks have been at the code hearings as long as I've been going, wanting to get some kind of something in the code so that it was an even playing field for everybody that used them and everybody that makes them. It's never made it into the code, but now it has. It's no requirement for them whatsoever. It's just another one of those where you use them. They have to comply with a specific standard. So now everybody has to use, all of the different radiant barrier manufacturers have to meet the same requirement. And so that's good. Then we get more consistency on what, at least the type of product that gets installed in the field. Not sure we'll ever get complete consistency on how things get installed in the field. But so where you use a radiant barrier, then they have to meet a certain ASTM standard. So that's good. All right, let's talk about paths of compliance. They really haven't changed in a few code cycles. I think since the 2018, they haven't changed. Maybe the name has changed, but the concept hasn't, right? So we still have our prescriptive R value or U factor method. That's prescriptive by the book. Just you get what you get and you don't throw a fit, right? And so you have a prescriptive table, you do what it says. Some people like that. They just want to be told what they have to do and they do it. And so if you go prescriptive, that's just basically putting on plans everything that is shown in those tables and in the code sections, making sure that everything's on the plans. We have another prescriptive-ish, they call it prescriptive, but it does allow trades, is the component performance alternative. Most of you are familiar with that. Used to be the total UA. That's res check, or if you use the rater software like Ecotrope or RemRate, it's the UA compliance. It's still called that in the software, but in the code, it's called component performance alternative. not quite performance because it's only looking at the performance of the thermal envelope. It's not looking at mechanical and lighting and everything else. So it's not full building performance. It's just a component, the thermal envelope assembly performance. And so why component performance alternative instead of total UA? That's just what it's been called for years in the commercial. Residential always called it total UA. Commercial called it component performance alternative. And so just for consistency's sake, it's here. This is the path where if they say they're going to use this path, they're going to turn in a res check, or they're going to turn in some, it doesn't have to be a res check. Most people do that because it's a free software program that just kind of does the calculations for you. They could totally turn in a spreadsheet or something that does the calculation, or they can use, like I say, those energy rating softwares like Ecotrope and RemRate will also calculate it. So there's not a specific way to do it. I have seen some jurisdictions that say, oh, you have to turn in a res check. That's fine, but there are other ways to do it too. Total building performance, that's R405. That's been in there since the beginning of time. It's switched almost every other code cycle. Total building performance, simulated performance, total building performance, simulated. It's back to total building performance. So we'll see how long it stays that, but that's that R405 section. R406 is your energy rating index. That's using the score, same software, same people in these two paths, building performance and energy rating index. Same software, same people, same process. It's one's using cost or BTUs, and the other is using a score to show compliance. So we'll look at them briefly at some of the changes. So if somebody's going prescriptive with the R value method, this is the table, right? I think this is the table. People open that energy code book and they look at it and they're like, oh my gosh, what do you want me to do? And this is the one place where I say, please turn the page, right? Like, if you're going to complain about the energy code, is because you're using this table. It's the most restrictive. There's not a lot of options there. It's throwing stuff at this because like people don't want to mess with software programs or other things. So just tell me what I have to do and that's what I'll do. Okay, but it's going to be really restrictive, right? And so a couple changes that you'll notice. Again, trying to bring consistency between commercial and residential. Residential, the table used to always have the components across the top and the climate zones down the side, but commercial had it this way. Well, now they're making them to match. So you find your climate zone, go down, and there's the requirement for each one of your components of the thermal envelope anyway. Couple changes here is they added this insulation entirely above deck. That's never been in residential. It's always been in commercial, but we're starting to see more and more flat roof houses with insulation above deck. And so they've just added it to the category, to the component list here. So everything else hasn't changed too much. Just some things to point out. Don't forget about those footnotes, right? They really do mean something. If there's a footnote in the title of a row, then it applies to everything in that row. If it's in the title of a column, it would apply to everything in the column. If it's in just a square, then it only applies to that square. So don't forget to read those footnotes. There's some valuable information in there that helps us comply with the code. So that's your, there were some rollbacks, if you will, in the 24 for this table. Especially if you see ceiling R value, if you remember, if you were on the 2021, those R49s went up to R60. They came back down to R49. And so some people are liking that. It was some wheeling and dealing going on because in the beginning, the electrification and the EV charging and all of that got proposed. So there was some give and take by all the parties to say, okay, we'll roll back this table if you agree to our EV charging or our stuff over here. And so they made all of these arrangements. And then at the end, the IECC board of directors took out all of those EV and electrification stuff and put them in an appendix chapter. But all of these changes got made. So it might be a little bit of a rollback in this table, but it's not a rollback in the code as a whole. There's still energy savings that were gained, 7 to 8% energy savings that were gained overall for the building because of other changes. So just because it looks like we went back doesn't mean as a whole building that we did. So just some clarification. U factor, this again, same here. Don't forget this table has changed a little bit in how it's laid out. Not a lot of changes. I do want to make sure when you're looking at vertical fenestration, if you're in those climate zones that are getting to a higher altitude, climate zone 5, 6, 7, and 8, there are footnotes in there. This footnote D, what this means is it tells you that the code requirement is 0.28. But as soon as you get over 4,000 feet in elevation, then the footnote tells you, oh, it's 0.30 instead of 0.28. So all of your software programs like ResCheck or your performance software are going to hold you to the 0.30 and compare you to the 0.30 as they're making trades because of this footnote. It's just because the argon gas sometimes that we use to get those lower U factors, it kind of, you lose some of it once you get over elevation, and it doesn't hold it as well. So realizing that they've changed that. So just be sure you're looking at those. This U factor table, I've never seen anybody go total U factor for the house. Usually if they're going to do that, they're going to go with ResCheck, the component performance alternative with ResCheck. One thing that I do want to bring in is don't forget that now F factors got brought in. So you're going to see U factors for a lot of things in here. But then once we get to the slab, F factor. For commercial, it's always been the UC and F factor table, right? You have F factor is for horizontal concrete floors, slabs. C factor is for vertical concrete walls. The residential never had it in. That's why if you're on the 2021 code, you'll notice that you can't trade off slab edge insulation anymore if you're using ResCheck. It's because F factor wasn't brought in. Well, now you can, if you're using the 2024, you can start trading that slab edge insulation off again because F factor got brought in. And so now the software can make that trade. So that's good to know. That's another positive from going from the 21 to the 24 is that you can go back to trading that slab. Some people don't like that detail, and that's an important trade for them. All right, let's talk about component performance alternative. That's that ResCheck, or that used to be total UA. It's using that exact same U factor, F factor table in the code. It's just behind the scenes. And so it's that free software that you can go in and go on the website and just put in your different components of the house. What are you using? 16 inches on center or 24 inches on center? Are you using 2x4s? Are you using 2x6? Are you using scissor trusses or raised tilt trusses? You just tell it how you're building the house, and then throw in whatever insulation you're putting in, and it's behind the scenes calculating the U factor and letting you know if the whole building as a whole meets the total U factor for what you're trying to do. So like I said, I've never seen anybody calculate it manually, but you could. So if you were using this path of compliance, you would either have to turn in a ResCheck, you would turn in the calculations that show how you came up with the U factor for the whole assembly, right? Assembly U factor means the frame, the insulation, the drywall, the air film, every piece of an assembly gets looked at to get the U factor and the total square footage of that. And so most people don't want to calculate that individually. they'll go into the software and do it. So you would look for that kind of software in this path of compliance, or that kind of report in this path of compliance. It's the first real start of trades, and where you can take something that you're doing that is meeting code or better than code and trade it for something that you don't want to do, right? It's like a checking account. What I always say, like these performance paths and this performance alternative path are like a checking account. Anything I do better than code is putting a deposit in my account. Anything I do worse than code is taking a withdrawal. I just have to stay in the black. And so I could put in maybe a better window because I don't want to put in the whatever insulation in my ceiling, right? As long as I can get the total U factor in the end to be okay, I'm good. And so that's where that code is telling us we have to provide flexibility. We're going to give you lots of options. And so you just pick which path you want and make sure you turn in the appropriate paperwork. So this one would be a calculation of all your envelope areas and their U factors to make sure that the overall stays within budget. ResCheck does that for you, so most people use that. Total building performance is R405. That's that. This is looking at more than the thermal envelope. This is looking at the thermal envelope and how it performs, but it also brings in what's your air movement, what's your air leakage, what's your duct leakage, how much lighting do you have, where are you putting your ducts, right? Like it's looking at all of the building as a whole, the total building and how it will perform, not just the envelope. And so there's a little bit more trade built here. So because you can say, oh, I'm doing better than 4 ACH or 5 ACH or whatever it is for where you're at. And so now I can use that where I'm doing better to get out of something somewhere else, or to do less than somewhere else. It's not very likely you'd totally get out of something, but you could use it to trade down. And so it just looks at a little more. Something I want to point out in the 2024, if you're using it, and a lot of people don't know this, because remember I mentioned that electrification, and EV and all of those things went into the code when it first got written. And then at the very end, the ICC Board of Directors pulled it out and put it in appendix chapters, the missed section. So this is the only path in the whole code that has a penalty for using gas, which all of the gas versus electric went away and went into the appendix chapters. They just forgot it here. So you're going to see in 405 where it's telling you, hey, for every dwelling unit with one or more fuel burning appliances, you have to be 20% better than the standard reference design. So 80% of the standard reference design. But if you're doing electric, you only have to be 85. So you only have to be 15% better. Why do you have to be better? This isn't meaning better than code. It's meaning better than the standard reference design. And that's because in R408, they brought in those additional efficiency packages. So if you go prescriptive, you have to do everything the code said, plus go pick, something better to get your building that little extra oomph of energy efficiency. Well, the softwares don't have that. So you're going to get that same oomph within the software by being 15% better, having a score or a cost that's 15% better. Well, here, when all of the electrification stuff got entered and it said, if you go gas, you have to be 20% better, I immediately wrote to the IECC and said, why is there a penalty for gas only in this one pathway? You can't have a pathway that is more restrictive than all of the other pathways like that, or have a penalty for a fuel source. And they said, yeah, they just forgot to take it out. And I said, well, then let's make it an errata. And they said they couldn't because it never went through the code development process. It was something the board of directors took out and they forgot to take that one section. So it's going to have to be amended at the local level. So easy amendment, just put a strike through those lines, right? So that now it just says all dwelling units have to be 15% better, right? So just a heads up. there shouldn't be a penalty for gas in one path of compliance and not all the others. If you're going R406, this is the energy rating index. This is the way, I mean, when I just look at the future, this is the way I see it. People want to get to net zero. People want to, you know, like, how do you figure out what net zero is? It's just so easy with this scoring method, right? And so I see a lot more jurisdictions that are going above code or trying to set net zero policies are getting to requiring R406, which is this energy rating index. And so you have a score of 100 is a 2006 house. We're trying to get down here to zero net energy. Not saying you're not going to use energy, but you're offsetting as much as you're using. And so it ends up being a net zero. So there's this scoring program. There's the backstops in it have changed over the code cycles from year to year. 1 minute it's, oh, you can't be worse. Your envelope can't be worse than the 09 code. Oh, your envelope can't be worse than the 18 code. Oh, your envelope can't be worse than 10%, you know, of the current code. It changes every year. Why do they have a backstop in there? Because there's so much stuff you can trade in this path that you can't trade in others. I could put it in a high efficient furnace and get out of some other requirements where, well, why would I say, you know, a furnace doesn't last the life of a building? Why do I get to trade some of that for a wall that might last the whole building, right? Like, why they don't have the same life cycle? Why do I get to trade them? Or they say, because this one you can throw in solar to lower that score. Well, the solar might be leased. It might go away. So what? Then what happens? Then I'm left with a house that's less efficient than in the other paths. So they're like, okay, you still have to build a good envelope, and then you can do these other things to lower the score. Well, now that new backstop is using thermal envelope, thermal conductance, right? How does energy move through that wall? It's got a calculation that it's looking at for that. So that's the new backstop. And then now it, you know, each cycle, it's a different scores that you have to get. And now it's got 2 scores. And so you have to get a certain, if you don't have on-site power production, right? If I don't have some renewables on there, I don't have some on-site power production, then here's my score. If I'm using on-site power production, then here's my score. It's just what this is trying to say is you can't just throw a bunch of solar on there and take it all the way, take it all the way to zero. You only get a certain amount of credit for the solar. You can put however much you want, I guess, but you don't get credit for all of it. So you can only get a certain amount of credit for the solar because it still wants to make sure you're building a really good house in case the solar goes away. So that's the new table. You know, if you were required to have a 54 without solar or a 43 with, you know, with on-site power production, doesn't have to be solar. But so that's the new table. When I've talked to some friends that are sitting on the 2027 residential energy code, they have said that there's very little change in the thermal envelope requirements, that more and more stuff will start focusing on the other aspects of the building, but that they've gotten the envelope practically to where it, you know, where they can take it. And so that was interesting to hear that they're not going after a bunch more on the thermal envelope. So just interesting there. All right. If you were on the 2021, you saw this R408.2, this additional efficiency package. This came into commercial in 2012. Some people say the name is kind of, I don't know, misleading. Some people say, oh, you want me to get more energy efficiency out of the building. You want me to go above code. And that wasn't the idea. It's in the idea of keeping with flexibility to say, hey, we need X amount of increase in efficiency out of the buildings, but we can only crank it down so much without, and then we take away the flexibility. So we're going to crank it down a little over here prescriptively, and then you tell us how you want to get the other 15% or the other 8% or 10%, whatever it is. And maybe it's 5%, right? And so in the 2021, it was 5%. So you pick, you either put in a better envelope or better cooling equipment or better water heating, you pick how you want to do that, but you have to pick one of those. If you go prescriptive, you have to pick one. If you go performance, you either pick one or do better on your energy costs. If you go ERI, you just have to be better score, 5% better score. Well, that all went away. I mean, it's still there, but it's just different. What we've learned over the years is why should I get more credit for a high efficient furnace in Florida, or why should I get credit for a high efficient air conditioner in Aspen, right? And so not every climate is the same. They shouldn't get the same credits, shouldn't be able to use them the same. So they changed it to be this point system, right? So R408 now only applies if you go prescriptive, which means also total component performance alternative, res check. It just doesn't apply to R405 or R406. So if you go with a prescriptive method, U factor method, R value method, or component performance alternative, you have to do the additional efficiency package. So that's the first change. And then it just says you have to get some credits. If you're building a new house, you have to get 10 credits from at least 2 measures, right? And so it's looking at a table. And for the first time, house size plays a role, right? You're going to start seeing this more and more in all the codes coming out, wanting you to build smaller houses. If you go over 5,000 square feet, now you have to get more credits. You have to go a little bit above and beyond in your efficiency measures. So this is how it's laid out. Also, each measure has to comply with its code section. So there's a table, you find the points, and then once you figure out your points, you have to go to the code section and do exactly what it's talking about in the code section. So every measure in the table has its own code section with more clarification. And then each dwelling unit or sleeping unit, so if you have like a R2 or a townhouse or whatever, attached housing, each dwelling unit or sleeping unit has to comply with the measures to earn the credit, not the whole building, right? So all right, what do the tables look like? It's it's kind of like commercial. Here's the code sections for each measure, here's the measure, and here's the climate zone. So not everybody's going to get the same kind of thing. I'm not going to get points for a reflective roof in cold climates. I'm going to get credit maybe for it in climate zone 0 or climate zone 1. I might get some credit for that, right? I'm going to get a lot more credit for reducing my thermal envelope thermal conductance in really cold climates than I am in really hot climates, right? And so, or I might say, like here, I'm going to get points for a high efficient furnace in Aspen, but I'm not going to get it for in Guam or Puerto Rico, right? Why give them that many credits? So the idea is, anybody puts in a ground source heat pump, they're going to get a lot of credits. You could get all your credits right there. You only have to get 10 if you're under 5,000 square feet. However, don't forget it said you have to get it in 2 measures. So even if you got 21 or 18 points, you still have to do another measure because you have to do at least 2 measures. So don't forget that. So all kinds of, this is just only partial of the table, all kinds of them showing you what to do. If you're high performance gas, you're gonna get more points for 95% than you are 90 versus that's what all of these are saying. Go to the code section to see what they're talking about. So you have to do that. You have to get 10 points. If you go prescriptive, you get 10 points. If you're under 5,000, if you're over 5,000 square feet, then you get 15 points from at least 2 measures. All right, a couple of little things that just real quick, slab on grade insulation. Almost every climate now is going to require slab edge insulation. It's just talking about we're trying to protect the edge of the slab where the heat loss is. This boilerplate, what I see come in all the time for these houses. And so it's just saying, hey, you have to start at the top of the slab and go down. None of that has changed. What changed is it only used to apply to slabs less than 24 inches, and now we're at slabs, less than 12 inches. Now it's slabs less than 24 inches. Once you get more than 24 inches below grade, the ground is providing enough insulation. So, but again, can be traded off. So don't freak out about that. The new air barrier and insulation table, I mean, it's not new. It's been in there since 09. It's got cleaned up to make it a little bit more user friendly. No real huge technical changes in it other than adding a place on air sealing at common walls. Some friends of mine, Robbie Schwartz and some other friends that have worked in the industry for a long time, got together with the UL and with the fire guys and try to figure out how do we get air sealing in common walls without voiding the listing of those rated wall assemblies. They finally worked together to come up with this. And so basically what it's just saying is that you have to have an interior air barrier. You need to have air sealing at these common walls. So you could do that two ways. Either install a fire resistant rated assembly that shows what they allow for air sealing. Some of them have been tested with these air sealing, whether they allow foam or they allow, whatever they allow. Some of them have been tested that way, but most have not, and they don't want to go back through the testing because it's tens of thousands of dollars. So they have agreed to write up a sheet that says what they agree to. So you either go in accordance with their approved rated assembly or be supported by approved data. So they've come up with data sheets saying, here's what you can do. And so you just have to go, like if somebody says they're going to use this UL wall, you go to UL. Do you have a data sheet for that shows me the air sealing that's allowed to be used? And so that's just a new section there that got brought in so to allow more air sealing at those walls. Blower door testing has changed a little bit. It saw a few changes. One is the main one is if you're in climate zone 6 through 8, it went from 3 air changes an hour to 2.5 air changes per hour in those colder climates. And so that's one of the big changes. It also is allowing you to trade it off. So you can go, if you go performance or ERI, you can go to 4 ACH as long as you're making it up somewhere else and you can still pass, right? You can trade that. And it did bring in some exceptions. It's really hard to get an ACH 50, like a 3 ACH 50 in a really small house. The bigger the building, the more volume of air, the easier it is to pass. And so they brought in an exception for smaller houses to use a CFM per square foot instead of an ACH 50. And their sampling got brought into the code. So like if you're doing, multiple units, attached housing units, you can sample instead of doing every single unit. There's a sampling protocol that got brought in. So that's nice. Ductwork has changed. Ductwork is one of those things, like especially if you go performance or ERI, you could get a really good credit for having your ducts all inside conditioned space. But what if I do this? Like I put them all in the attic, the unconditioned attic. Is there any way to still get a good credit for them? Yeah, so there's space conditioning. You can call your ducts inside the envelope, inside conditioned space, which is a big trade, big credit, big deposit into your checking account, right? In some of those trade-off paths, if you have your ducts in conditioned space. So they either are considered inside the conditioned space if all the space conditioning equipment is located on this side of the air barrier, right, on the internal side of the thermal envelope, and the duct systems are located within the conditioned side of the thermal envelope, right? So that's pretty simple. Put everything inside the envelope, it's inside conditioned space. Okay. But you can also call them inside conditioned space as long as they're buried. Like you put your insulation in the attic and you put them in and you bury them in insulation, and it's a very prescriptive. It tells you how much insulation has to be on the bottom and on top and all the way around it, plus the insulated duct and all of the, you bury them according to the code. Your air handler is inside the thermal envelope. They don't leak very much, right, per 100 square feet. And your ceiling R value meets its certain requirement. There's a way to bury your duct in that ceiling cavity and still meet the buried duct inside the envelope and your ceiling R insulation requirements. The home builders work really hard to get some great stuff in the code. And so there's a way to do that. And if you do that, you can call your ducts inside conditioned space and get a really good credit for it. Duct leakage changed, right? So now you have this duct leakage. It's used to be, you leak 4 CFM. Well, now it's dependent on the size of the house, more than 1,000 square feet or over 1,000 square feet, how many ducted returns you have, and where your ducts are located. Is your equipment in conditioned space or outside of conditioned space? Now it tells you if you're over 1,000 square feet, depending on where your equipment and your ducts are and how many returns you have, here's how many CFM per 100 square feet you can leak. If you're under 1,000 square feet, you can leak this many CFM, not per 100 square feet, just CFM, right? So it's changed quite a bit and brought in sampling for duct testing as well. Lighting got brought in 2021. Crazy. Now we have light. We've always had the requirement for high efficient lighting. Now it's at 100% of the lights have to be high efficacy, well, except for those, lights inside your stove or refrigerator. But all luminaires in a habitable space have to have a dimmer or an auto shut-off control that turns the lights off within 20 minutes. So again, you have to look at your definitions to see the definition of habitable space. Any luminaires in garages, unfinished basements, laundry rooms, utility rooms, or the like have to have an occupancy sensor. So that's new. Controls came in 2021. It was really crazy to figure out what it really meant. So they reworded it in 24. But you do have lighting controls, and you also have exterior lighting controls. R2, R3, and R4 has exterior lighting power density requirements, meaning watts per square foot you can use outside. But if you're more than 30 watts, you also have to have controls that manually shut them off or automatically shut them off. Lighting has to shut off when there's no daylight, or when there is daylight, your whatever form you use, as soon as it's daylight, those lights have to shut off outside the building. And then of course there's always override controls that are allowed. But so some new lighting requirements in 2024. Most of them came in 2021. They just kind of tweaked them to try to make it easier to understand. When you look at renewables, this is, again, there's this thing in there, renewable energy certificates. Because all of that electrification stuff came into the code, so did RECs. RECs came in, but when they took all of that out, they left RECs but only saying when you do renewable energy, you need to do RECs. Most jurisdictions are amending this out because they do not want to track the RECs from owner to owner, back to the original owner, because it's non-transferable. But it is in there. It's not that you have to do RECs, but when renewable energy is used, then you have to provide that documentation. Lastly, is chapter 5, this existing buildings, right? To say the biggest change, I think, for existing buildings is the renewable. Yep, I'm going to form a sentence. The biggest change is those additional efficiency credits that never apply to existing buildings, now do. So if I do an addition, It's always been in there. New construction has to comply. It is new construction. You're building an addition. It's new construction, so it has to comply with the code, right? It can't require unaltered portions to be brought up, can't create an unsafe condition. All of these have been in there forever. Can't overload an existing system. Can show compliance by yourself or as a whole building. Well, now we start getting into some of this. You have to meet the air barrier and air sealing requirements, but you do not have to do blower doors in additions, right? New windows have to comply with the U factor and solar heat gain coefficient. New mechanical and water heating has to comply as new construction. If you use an existing that you're pulling over from the rest of the house to do this addition as well, then that's not. You can't overload an existing system with that, so you have to make sure that it can handle it. But unless it's new, it doesn't have to meet the mechanical requirements. New lighting systems have to meet the requirements. If you change from unconditioned to conditioned, then you have to comply with the code with R502 for additions. But you could go UA or performance, and you could be 10% less than code, right? Which is say, like, I have an existing building. I have this, I'm attaching an addition onto an existing building. There's going to be some issues there. What is my U factor of this, a wall I'm attaching it to? There's just things that happen. And so it's going to allow you a little bit of leniency there, that you don't have to be 100%. This is the big one. Additions have to get at least 5 credits from that table. So, and there are some exceptions in there, so definitely become familiar with it. But we never had to get additional efficiency credits on existing buildings before. Now you do for both residential and commercial. So pay attention to that. If you're an alteration, again, not much has changed. You have to have a continuous air barrier, or you have to install, if you take drywall off, you got to make sure there's an air barrier in there. A lot of times your drywall is your air barrier, but you have to have a drywall or an air barrier. It's just saying, like, it's not going to make you do a continuous air barrier for the whole building, just each part that you touch. You can't make things worse than they were. So, you have to comply with the insulation. You might be trading things off, and that's fine. But if you had R13 in there before, R13 has a minimum has to go back in. You can't take it to a lower value, even with your trades. Recessed lighting has to be air sealed. New mechanical, new water heating, all of new has to comply. New has to comply. And then you have to get 3 points from the additional efficiency tables, which you never had to do before. So just pay attention to that. That's a big change, I think, for folks. All right. Remember, we said all of those things that got pulled out of the code and put in an appendix chapter. Here they are. You can see you have electric energy storage, electric vehicle charging, alternate building thermal envelope R value options, a stretch code option, carbon ratings, on-site renewables, demand responsive, all kinds of fun stuff that got pulled. This was all in the body of the 2024 when it got written. It got pulled out. ICC was like, hey, this is good for those who want to go there, but this is an international code. Not everybody can do this as their minimum. And so they pulled it out and put it in the appendix. There's some stuff for all electric buildings that they weren't even willing really to make an appendix for, so they made it as a resource. You can use it if you want to, it's there, but they're not even going to call it an appendix chapter. And so that's in there as well. All right, so that's your new 24 in a huge nutshell. I just want to real quick, because this code said, hey, what's coming next? I just want to have a real quick conversation of what I see on the horizon, whether it was from the 21 or the 24 that got written and it got pulled out. But I see a lot of states now bringing it back in. And so I just want to talk to you about a couple things, whether it's jurisdiction or your state is starting to bring electrification. What does that mean? Electrification is just that, right? We're going to replace those gas or fuel burning appliances with electric equipment. and most people, it's for the furnace, the heating and cooling and the, but it's all over the place. It could be any appliance or only some of the appliances and anywhere in between. So what is electrification? Most people are looking at trying to make electric ready, but there's so many different levels of that. You have electric ready, where I'm just going to pre-wire, I'm going to run the conduit. If I have a gas dryer, I'm going to run an outlet for a electric one in case the new homeowner wants to switch them out. It's not that simple. A gas dryer takes a 110 outlet and an electric takes a 220. So you're going to have to put in both. Maybe it's going to make builders decide to go one way or the other, right? And I'm sure that that's the idea. But I'm going to save capacity on my stuff, but I don't have to actually put in electric appliances. I'm just making it ready. If I do that at new construction, it's cheaper than tearing up walls and floors and everything afterwards. That's the idea, right? You have electric preferred, which some people are doing. It's just saying, I want you to go, which is, I want you to go all electric, but I don't want to require you. So if you go gas, you're gonna have to do these extra things, kind of like that was in that performance path. If you go gas, you got to be 20% better, but if you go all electric, you only have to be 15% better, right? Some people are doing it that way. They're going to incentivize you by having less requirements if you go electric. That's called electric preferred. Electric only for space and water heating. They're saying you can have a gas dryer, you can have a gas cook stove, but for your water heating and your mechanical, they have to be electric. Some are doing that. Then you have just complete electric only with a couple of exceptions. They're saying we want your gas dryer, we want everything to be all electric, except for you can have maybe, a backup generator that's going to be fuel sourced, or maybe for restaurants, you can have that gas cook stove. For commercial kitchens, some labs, some emergency equipment that handles emergency loads, those could be not electric, but and so there's those are the main types of building electrification that I see. Why we want it, most everybody is requiring it for new buildings, because existing buildings kind of, it's harder to do for existing buildings. Trying to get it at new is the idea, right? That's where the money is saved by doing it at time of construction. Some questions that I see all the time: are utilities ready? Can the grid support the extra load? Well, one, we're building better houses, so we're not going to have as big of a load. And two, yeah, the utilities know, they've been involved in this for a long time. They know this is coming, so they're getting prepared. And plus, it's not all happening at one time, a house at a time or whatever. It's not like every single house in the city is going to turn on at the same time. It's like, okay, this house was built today. There's still a lot of existing structure that isn't electric, right? So it's going to be sporadic and over time. What if there's a power outage? Well, if there's a power outage, your gas stove isn't going to work either because it has an electric igniter, right? If there's a power outage, we're all going to be relying on something for backup. And so you have to think about those things. Can heat pump work in cold climates? Absolutely. It's picking the right one, right? It's not necessarily about high efficiency heat pumps. It's about the climate that they can operate in, and what capacity can they meet. They're rated to get 47%, I think, capacity at a certain temperature. And so you have to just make sure that you're getting like 95% capacity can still be reached at 5 degrees instead of picking a certain HSPF. How does it affect affordable housing? How does any code change affect affordable housing? I think the idea behind affordable housing, that it's affordable to run, maybe not so much to build. I don't know. That question will always be out there on what do we do about affordable housing. All right, some pros and cons, just real fast, and then we'll be done. Is energy independent country, right? Yes, electrification, a pro is that we're becoming energy independent. We're not relying on others for some of our fuel sources, right? Is there maybe some economic growth because some of these technologies, heat pumps and different things, are going to require more specialized contractors? That can be a pro and a con, right? But thinking that maybe there could be some job growth by having new technologies, new knowledge, better environment indoor and out, right? Less carbon emissions, cleaner, clean, it's at least cleaner. Highly efficient equipment, almost all of that. You take a heat pump, the efficiencies are through the roof. And so definitely a benefit. This is a pro and a con, I think. Less expensive construction costs than a mixed fuel building. Why is it less expensive? It's less expensive on this side because I'm only putting in one utility. I'm not running gas and electric. I'm only running electric. And so why would I, yes, it's more expensive to do both gas and electric. That's one side of it. So when we get to cons, we'll see the other upfront cost. You can offset with renewables. You're going to have to, right? You're not going to want to have this big, huge electric bill with you're going to want to offset it with some renewables. And so that's nice that you can offset it with something, right? What are some of the cons? More expensive upfront cost because maybe, because you do have to pay that more experienced laborer, or you do have to pay for a heat pump that might be a little bit more expensive or whatever. There are some more expensive costs there. There's also, it can be more expensive monthly. We have this thing called beneficial electrification. There's all kinds of things that make it beneficial. One is it's beneficial if electricity is cheaper than gas. That makes it beneficial to go electric, but very rarely is that the case. So it might cost you more to go all electric unless you offset with some renewables. One energy source dependent, that gets a little scary, right? What if something happens? Requires backup energy equipment, definitely. Electric power comes with its own safety hazards, but so does installing gas and carbon monoxide fumes and all of that. So I don't know, that's they both have their cons there. Some equipment takes more room. And so this is what I really want you to remember, that like a heat pump water heater, it's bigger. And so that little closet that you put it in now has to be bigger. And you have to think about that up front because the NEC also requires more clearance for a heat pump water heater. And so you're going to have a little bit more room there for that on the inside of the building. Some of the equipment outside of the building, if it's serving the whole house, it gets bigger, right? Transformers are bigger, things are bigger outside. What does that look like? What is zoning going to say about this? Where's it going to go? So lots of things to think about on the electrification, but it's coming. It's coming. All right. That's it for me. If you're in Colorado, I would love for you to, one of the requirements for me to teach classes is that I get you to register and then I get you to fill out a survey, right? So please, I know this is kind of feeling like really fast, what's coming, but it's just the tip of the iceberg. Please go look at the code. But if you're in Colorado, please do the survey. I appreciate it. And so now I think, Mike, we're at questions.
That's right, Shauna, and definitely a call out to our audience. If you have any questions, go ahead and send those in via the Q&A box. We certainly have a couple here for you, Shauna.
Yeah. Great.
So Connor has a question on sampling.
Yeah.
Is it based off of one of the ANSI or the ASQ sampling standards, or did they just make up their own?
Great question. No, they did not make up their own. ResNet and all they're all involved in this co-development process. So yes, sampling came in and you use ResNet protocol. What is it? ANSI. I don't have it off the top of my head, but yes, it is definitely standardized.
Okay. A question from our friend Howard out in Hawaii. Is there any credit for reflective walls?
For reflective walls. Huh. Well, because this code brought in thermal conductance, I suppose there could be some type of credit for that. You're probably going to get more of a credit using the performance path than anything else. But I have to think about that one, Howard. That was a good one.
Okay. Uh, Connor sent in the comment that ResNet doesn't have an ANSI standard for sampling. Is that correct?
Yeah, there's a standard. I'm trying to pull up my code to find it. Let me see here. I don't know what you guys are seeing, but so I just want to make sure. Let me just pull up
Oh
the
yeah, the sampling's for multifamily, but not single family.
yes, right there. You can't like yes, if you have a big subdivision, you can't test every other house, right? It's just for multifamily for attached housing, right? And so that is um, what is allowed to do that. I'm trying to find that, sorry.
So we also have a question coming in from Netanaya, saying that, it was already a struggle to find hurricane impact windows and doors that met with the code requirements. So with the new updates, are manufacturers being informed of the need to meet lower U factors?
Well, that's a great question. And just remember, I know I only mentioned it for high altitude, but that footnote is going to be key for you for the hurricane resistant glass, because that footnote says, if here's your U factor, the table says here's your U factor, and that footnote says, if you're over 4,000 square feet or you're in those hurricane, you need that protection, you can use this other U factor. So no, rely on that U factor for those areas. It gives you that credit for a higher U value for those windows.
Okay. I had a couple questions for you too that I'm going to interject in with the others that are coming in from the audience. You listed off those appendices. Um, wasn't there at one point a net zero appendix?
Yeah, there was for residential. I think it might still be there. Let me look here. Yeah, there it's appendix RC, which is a net zero option, zero net energy residential buildings. Yeah, RC.
Okay. Okay. So it's still in there. Were there any changes to that?
Yes.
We don't have time to go over all those now, but
It's really it's because that appendix chapter relies on R406, the additional or the energy rating index path. Any changes that take place in R406 will automatically have to go over and take place into this zero net energy one, because it relies on that path to show compliance. So most of the changes you see there are changes that took place in R406.
okay. Okay. Robbie, our friend Robbie, wanted to share that how you do the sampling is spelled out in the code. So it is in there. He copied and pasted the section
Oh, we
for
did.
me.
Oh, good, good.
Yeah. So it is in there for those who are wondering where it's at or looking for it. It is in there.
Good, because I was just trying to find it.
Yeah.
Sorry.
Um, is ResCheck a software program that can be used in all states?
Well, I mean, it could be, unless your state has an amendment that doesn't allow it. But the software program, I'm not aware of a state that they can't make it for. They will. There are some issues, right? Like, so if you have a state code and your state amends the code, it's harder to use ResCheck. Now, PNNL will make a state specific one, because if you amend it, or a jurisdiction one, I'm in Colorado, we're a home rule, somebody might amend a code, they will make a jurisdiction specific one to your amendments, but it takes a really long time because they're really backed up. And so it gets harder to use ResCheck if you make amendments, but I don't know that there's a state that, I mean, that they couldn't do it for, right? They can do it for all climate zones. Like I say, the only time that they couldn't do it for a state is if that state has so many amendments that now ResCheck won't work. I've run into that. If that is a problem where you're at, let me know, because I've worked with a lot of jurisdictions say, okay, we don't have time to get P&L to create you a new one or a specific one, but we can get them to analyze what's the difference in efficiency. And so now we just say, okay, your code, the way you've amended it, is 3% better than the code as written. So turn in a res check that passes by 3%, right? And so you can do it that way.
Okay. Another question came in from Connor wanting to know about the R406 ERI path. Um, does that score then have to be registered under an EPA recognized HCO like Building Science Institute or ResNet?
I haven't heard that it has. It's just that you have to have a score. You have to get a energy score. I suppose if you're doing it for the builder for marketing, it would go through ResNet or whatever. Well, actually, it probably would, because the software that you have to use requires certified users to do it. So if you're using like Ecotrope or RemRate or something like that to get to those scores, then you have to be a certified user. Those usually go through like ResNet or BPI or somebody. But does the code say it has to? Could I come up with a score on my own? I've never had anybody ask that to.
Yeah, Robbie's saying that it doesn't,
Yeah,
the code ERI doesn't have to get
the code
registered
ERI
there.
doesn't, right? If
It
you do
just has
a
to be
PERS
confirmed.
score, then it does, right? But if you're doing a
Yep,
ERI, I
right.
haven't looked in the code language that closely to say it has to be, but it doesn't seem like it. I agree.
Yeah.
I don't think it
Yeah, it
does.
just has to be confirmed, not
Mhm. A
registered or,
confirmed rating or a confirmed, yeah.
uh, yeah. So that's, that one's that. I had another question come in from Howard. Aloha, Howard. Can you
Mhm.
get credit for installing shading over windows?
In commercial, absolutely all day long. In residential, I can't think of a single place where you could get credit for it, not even in ERI, I don't believe, unless you could find a way to change the thermal conductance, you know, calculation. But yeah, I haven't seen that. No. In commercial, yes. So I suppose if you wanted to do it, you could pull from commercial that gives you, you can get a different window. You can put in a worse window if you put an overhang on it. I haven't seen that come into residential.
Well, and I'm just curious on that. Um, I would think if it's not in the code, looking forward to
Mhm.
potential future code amendments, there would be a difference between a uh, temporary shade
Yeah.
and something like
Mhm.
what was back in architecture, like in the 60s and 70s, which was the 2 foot overhangs,
Right.
that are more, a much more permanent.
Yeah, the commercial, I mean, if you wanted to bring it in, you could go to that commercial section in C402 and bring it in. uh, Be it's very specific on how big is the projection, how far is it, how, it's a calculation that you have to do. And it's a good calculation. It just tells you you can put in a worse solar heat gain coefficient window if you use that. It doesn't really go towards, well, I suppose it does go towards the total. No, it doesn't even go towards the whole U factor or the anything of the wall. It just goes to the solar heat gain coefficient of your windows. You can put it in a worse window if you put a shade over it. It doesn't do anything for your U factor of your wall.
Yeah, and I've got a couple comments coming in from people saying that
VR.
when you're modeling windows, it's going to ask about fenestration requests looking for overhangs.
Yeah.
And so there's potentially in the ERI path there could be some
That
benefit,
makes
some
sense.
credit there.
That makes sense that in the ERI and the modeling software that it would, because it does also make a big difference in like manual J, right? When you're looking, manual J is where you're trying to decide how many loads of heating and cooling it's going to take, and it takes that kind of consideration. So it makes sense that if it's modeled in manual J, it could be modeled in the performance software.
Yeah.
But again, it
Uh,
usually doesn't go to U factor as much as it goes to solar heat gain coefficient.
I wanted to put out a last call for questions from the audience. But I have another question too. And that was on the topic of trade-offs.
Mhm.
And you kind of talked about this a little bit, but I wanted to get a little bit more clarity on this. Is there any waiting involved? Waiting, not like wait around, but waiting
Yeah.
involved. Like for instance, the chances of upgrading wall insulation or slab edge insulation is probably lower than replacing windows or upgrading your ceiling or attic insulation.
Right. There's weighting probably more on the performance of the whole building when you're looking at total building performance in the software there more than there is in like res check, right? Res check is just looking at what is the U factor for U factor, and it's not looking at U factor over any type of time or in a specific location. I'm going to get, if I put in a better U factor, I get credit for that. But maybe in total building performance, it might have some weighting there to say, I'm not, I don't know. I think that would be a Robbie question on how the performance software looks at it, on if they would give you more weight for ceiling insulation that they feel does more than slab edge insulation, right? And if they weight it that way, but for the most part, it's R value or U factor for U factor, and so.
All right. Well, I don't have any other questions myself. I don't have any other questions in the queue for you. So I want to definitely say thank you, Shauna, for once again joining us. It's always a blast when you come and talk code with us. I know that some people go, oh, it's dry. But you know what? This is super important and super applicable to a whole lot of people. So thank you very much for being here. Really appreciate it. And for being so cool.
Hey, thank you for what is it? Cool. What is the day?
Smart is cool day.
Smartest cool day. Yes, I love it. I love it. All right. Well, thanks for having me. And sorry, we couldn't get into huge detail on everything, but it's a good place to start, right? It's a good place.
That's right. That's right. I also want to thank our wonderful audience for asking wonderful questions and being here with us today. Thank you to PowerShift by NV Energy for their generous sponsorship. They're definitely our code webinar partner and have been for years. So we really do appreciate them. Our next webinar will take place on Thursday, November 6th. It's part of our Housing 2.0 workshop series. And Sam Rashkin will be talking about managing homebuyer uncertainty. I don't know if there's any such creatures out there, but in case you know of any, kindly refer them to our webinar. That will start at 12 p.m. Eastern Time, so a little earlier than normal. Again, that's Thursday, November 6th at 12 p.m. Eastern Time. You can register for that at greenbuildermedia.com. Until next time, I hope you get a chance to go out and enjoy the fall colors. Have a safe and fun Halloween and, maybe take in some of the World Series. Stay safe, stay healthy, and take care, everyone. So long.
Thanks.